Hi everyone. Today we are going to discuss a beautiful concept called mesh analysis, which is very much useful for analyzing the behavior of any element for a given circuit. It is one of the network simplification technique which will be very famously used under the course titled electrical circuit analysis or network analysis. So let us start with what is meant by mesh. See, mesh obviously it is a closed path. Mesh obviously it is a closed path. Then what about loop, sir? Loop is also a closed path. If both of them are called by the same name, then what is the difference, sir? See, understand properly. Mesh is a closed path with no further loops. With no further loops. But loop is just a closed path. Okay, that is the main difference. So that's why in some books we'll mention mesh analysis or loop analysis. For analyzing this mesh analysis or loop analysis, we must understand that the concept of mesh analysis. The concept is mesh analysis involves the application of Kirchhoff's voltage law, which is famously called as KVL, plus Ohm's law. That means here we are going to find different currents using the basic concept of KVL. So Kirchhoff's voltage law. What is Kirchhoff's voltage law? Kirchhoff's voltage law is the algebraic sum of EMFs must be 0. The algebraic sum of EMFs must be 0. So using this concept we are going to solve the method of mesh analysis. So let us first understand the various steps involved in applying this concept. So steps involved. First step is, if you are given a circuit, then you need to identify how many number of loops are there, loops or meshes. Identify number of, let us say, closed paths. Let us say closed paths or loops or meshes or loops or meshes. This is the first task which you need to do whenever you are given a circuit to solve using mesh analysis. After identifying the meshes or loops or closed path, you need to assign currents. The direction is your choice, whether clockwise or anti-clockwise, that's your choice. Assign currents in each loop. After assigning currents, then we need to apply KVL for each loop individually. KVL for each loop. KVL for each loop individually. So after applying KVL, now solve for the required unknown parameters. Solve for required unknown parameters. So this is the steps involved. These are the steps involved in finding any required unknown parameter in the given circuit. For understanding this, what I will do is I am going to take one circuit. Practice problem from the famous textbook called Sadiku. For this Sadiku textbook, they will give practice problems with answers will not be mentioned. That's why. So, as shown in the problem, there are 3 closed loops: loop 1, loop 2, and loop 3, and several parameters or several what you call elements are connected there. I am not talking about this currently. So, while solving, we shall discuss. Right. So here one thing I have to tell you, that is how to identify the polarity of voltage source. See, if your voltage source is like this, let us say 20 volts as per the given problem. If you observe here, the arrowhead is going like this and touching minus sign here. If it's touching minus sign here, then the answer is minus 20 volt. Here in this second loop, here I am highlighting with yellow. So there is one more dependent source. How to identify the polarity is, see, the arrowhead is going like this and touching the minus sign first. So the answer for this is minus 10 I naught. So that's a very important thing which we need to identify very carefully. Once I am saying, for voltages the polarities are must and should written properly. See, in the first example, this I1 is coming like this and entering this at the minus sign, So since it is entering at the minus sign, here at the minus sign, so I will take the value as minus 20. It is touching first the minus sign. That's why the answer is minus 20. But here on the right side, I2 is coming like this and touching plus minus sign here. That's why here also minus 10 I naught is the value. I hope you are clear how to identify the values and all. So apply KVL to loop 1. In loop 1, how many elements are connected? Let me see. In loop 1, if you observe how many elements are connected, I'll highlight the loop 1. So in loop 1, if you observe 1, 2, 3. So 3 elements are connected in loop 1. 3 elements are connected. So that's why keep 3 brackets. That's why how many brackets? Keep 3 brackets. So therefore I am keeping 3 brackets. First bracket plus second bracket plus third bracket is equal to 0. Why? Because you have to apply KVL. KVL is sum of voltage equal to 0. So what is the voltage of first battery? What is the voltage of first battery? If you observe here, the arrowhead is touching minus sign first. Arrowhead is touching minus sign. That's why the answer is minus 20. Next, here across the 4 ohm, I need to identify what is the voltage here. Across 4 ohm, I need to identify what is the voltage here across this 4 ohm. So how to identify the voltage are very simple. As per Ohm's law, V equal to IR. Current into resistance. The resistance value is 4 ohm and the current value is how much, sir? Because if you observe, the 4 ohms is being shared by both the loops. The 4 ohm is shared by loop 1 as well as loop 3. That's why the current must be I1 minus I3. Why only I1 minus I3? Why can't I3 minus I1 means? Since I am applying KVL to loop 1, I will assume that loop 1 current is higher than any other current in the given circuit. That's why I1 minus I3. And the last one, here 8 ohms also is shared by both, here 2 ohms also is shared by both loop 1 and loop 2. Loop 1 and loop 2. That's why voltage is 2 into the current. So current is I1 minus I2. Why only I1 minus I2? Because I am assuming that I am applying KVL to loop 1. That's why my current value of I1 is higher than any other current in the loop. So on simplifying, my equation is 6I1 minus 2I2 minus 4I3 is equal to 0. This is first equation. Let us say this is first equation. Next. So again similarly, I'll take loop 2. For analysis of loop 2, here in loop 2 I have 3 elements connected. I have 3 elements in the loop 2. So what are those? 2 ohms, 8 ohms and 10 I0. That's why first bracket, second bracket, third bracket equal to 0. So in first bracket, what I have to fill? See, I'll start with here at loop 2. At 2 ohms. 2 ohms is the resistance which is being shared by both loop 1 and loop 2 separately. That's why the current across this 2 ohms becomes, this 2 ohms is shared by both the loops. That's why the current is being shared by both the loops. That's why here 2 ohms into I2 minus I1 I wrote. Why only I2 minus I2? Because I am applying KVL to loop 2. So while applying KVL to loop 2 current is majorly high than any other current in the circuit. That's why all I2 is assumed as bigger. That's why 2 into I2 minus I1. Here we should not write I1 minus I2. Similarly to 8 ohms, I2 minus I3, because here 8 ohms is shared by both loop 2 and loop 3. So here this one is loop 2 and this one is loop 3. That's why this one is loop 2 and this one is loop 3. So both the loops are sharing 8 ohms. So 8 into I2 minus I3. Why only I2 minus I3? Because we are applying KVL to loop 2. That's why current I2 is assumed as higher than any other current in the circuit. Last one, there is a dependent voltage source here, diamond source. How to identify the polarity? As I told you earlier, this arrow mark is touching, coming like this, and first touching minus sign, so minus 10 I0. But what is I0? I0, if you observe, I0 is the current flowing in 6 ohms. But what is the current flowing in 6 ohms? 6 ohms is I3. So this one is I0 and this one is I3. That's why I0 is equal to I3. That's why how much? I0 equal to I3. So if you substitute there, I am going to get my answer as 2I1 minus 2I1 plus 10I2 minus 18I3 equal to 0. Similarly, apply KVL for loop 3. If you apply KVL for loop 3, here this one is loop 3, here this one is loop 3. Let me highlight it. So this one is loop 3. In loop 3, how many elements are there? 3 elements are there. That's why I'm going to put 3 brackets. So this one is first bracket, second bracket, third bracket. Coming to first bracket, if you observe properly, here 4 is being shared by loop 3 and loop 1. But we are applying KVL to loop 3. We are applying KVL to loop 3. That's why third loop current I3 is assumed to be bigger than any other loops. So 4 into I3 minus I1. And the second current is 6 into I3, because that is the 6 is present only in loop 3, and the last current is 8. Here 8 is shared by, as I shown, 8 is shared by both loop 2 and loop 3. So 8 into I3 minus I2 is equal to 0. So number of I1s, number of I2s, number of I3s I wrote here. So all my 3 equations I have shown here. On solving all the 3 equations using a scientific calculator, I got I1 is minus 3.21, I2 is minus 9.61, and I3 is minus 5. I3 is what I shown in the figure, right? I have shown here. I3 is nothing but your I0. So the required value of I0 is how much? Minus 5. So my answer is also minus 5 I got. So this is how I can solve problems using mesh